Right. Thank you for joining us, Josh, to present the iTrace and in particular Toolkit. So yeah, take it away.
Alrighty, so hi everyone. I'm Josh. I'm going to be walking you through basically the entire gambit of the iTrace infrastructure and how to begin a tracking session all the way to how to analyze the data at the end. So to start, you need code to look at. For this demonstration, I'm going to be using iTrace Atom. However, you could be using any of the iTrace plugins that we support. We support Visual Studio and Eclipse along with Atom. I think Atom's the easiest to work with those, so that's what I recommend. But if you need something specific, those options are available. So to start, open up your code, bring it in. I just have some code from the Toolkit, some of the source code loaded up. And what you're going to want to do next is after you get it installed, you're going to want to launch iTrace Core. We do have instructions for how to install and set up everything. Dr. Sharif has that document. She should be able to forward it to all of you when that's ready. So when launch iTrace Core has these 4 different tabs. You're going to start on the session setup tab, and you're just going to fill out the data fields. The task name is what you're going to name the particular session. I'm just going to call it demo because that's what this is. Researcher name is your name or the name of whoever is conducting the session. Participant ID can be any unique number or identifying string for this. Usually it's your student number if you have one. And then the data directory is where output will go. So I'm going to quickly set this up to go to this output folder. When everything is set up here, make sure you click apply and it will save it. The next step is go to the iTrace tracking tab. This is where you set up stuff before the actual tracking begins. I don't have an actual eye tracker here, so I'm going to have to use the mouse tracker for this. But if you had a eye tracker here, such as a Smart Eye or a Tobii tracker, you would select it from this drop-down list and then calibrate it. And then the calibration would be, follow the circles with your eyes for a little bit until it saves the data. Additionally, you can toggle this to show the reticle. It won't start moving until the session is actually being recorded, but this will follow your eye or your mouse when the session starts. So after you've set up everything in this window you want, you're going to go back over to your IDE and connect it to Core. For Atom, you do this by going to the iTrace Atom tab, clicking init, and then after it's initialized, clicking connect to iTrace Core. So now this is all connected here. So I'm going to turn the reticle back on. And what we'll do is you just click start tracking when you're ready. So now you see up there, it says logging started by iTrace Core, and you can see the reticle is following my mouse. So this is where you would begin your session. You would go through, usually you have some sort of instructions for what to do. For this case, the instructions would be go to all of the .h files, and read all of the function names. So you would go through, look at them, read them aloud, scroll through, go through all the files. When you're done, you would return to Core and select stop tracking. Atom tells you that the session has ended. And now if we look at our output folder, we see 2 files. So let me open these up to show you what they look like. So the first one is, let me disable that so that's not in the way. The first one is the core file. The core file contains information about your eye gaze data and any calibration you've done. So right here has the environment. It gives screen width, screen height, what type of tracker you're using, etc. And then it's just this big list of every single thing, every single snapshot it got of your eyes during that session and what XY it was looking at, the pupil diameter, the distance to screen it got, all of that fancy data. And then the plugin file, in this case, it's Atom, but it might be underscore MSVS or underscore Eclipse, contains information about the IDE during the session. So it will have data, it will have a almost one-to-one amount of responses, but sometimes it skips over one. And it has information about where the thing was, but more importantly, what file was being looked at and what line and column the gaze was looking at. And that's important later because then we can take that line and column and map it to what word or token they were looking at. There's one more important thing I will quickly show about iTrace Core is you are able to do a screen recording with it. Now, you guys may notice that there is a checkbox down here that says enable screen recording. We're actually working on phasing this out right now. So you can use this, but the video you get will be a lot worse. Instead, what you should do is open up OBS. So it's going to go infinite here for a second, but we've developed a plugin for OBS that you'll set up. Again, we have instructions for how to do that, but you'll go to Tools, Scripts. You should have screen recording set up, and then you click Connect to Core. You can tell it works if it says connecting to Core here after you click the script log. So now if I go back to iTrace Core and I start tracking, as you can see, as soon as I click that, OBS started a screen record. And now, you would conduct your session as normal. So you could bring Adam back up, go through, do everything, go here, stop tracking. And so now if we look at our output, we have another set of plugin and core data along with a video. Oh, I hope that's not playing. Okay, there we go. So we have a video here of the entire session I just did. And if you set it up to record your voice, it'll record your voice. The cool thing about using OBS is you can set it up however you want it. So like I said, if you want the person who's conducting the study to have their voice be recorded, you could do that. You could record different screens. You could record both screens. There's a lot of stuff you could do, but that's all OBS stuff. We won't be going over that. So now that we have this data here, the important thing to do is now look over it and be able to perform analysis on it. However, we need to first get one more file. This is called a SourceML file. SourceML is a way of marking up a language into an XML style. And what it does is it lets us have fine detail over our over what the starting position of every single element is. So to generate this file, you'll go to where your source code is kept, and you'll open up the command prompt there. And what you'll do is you will run this command. Can everyone see this? I can make it bigger if you guys can't read that. Okay, so we will change input files. I believe I just have to do dot to select this folder, and then you change output file to be, we'll call it demo.xml. So if I run that, there's this demo.xml file. So when I open this up, you can see that here's the comment at the top of the file. And if you look at all of the black text in here, it is the exact same thing as our source code, but marked up with these tags such as function with position, line 28, column 1, ends at line 71, column 1. And it marks up every single bit of code with a corresponding tag that tells you exactly what it is. And this is important because you can do analysis on this. So you can say, I want to know when the user looked at an if statement that's inside a function. You're able to get that fine and nitty gritty with what you look at. But now that we have this, I'm just going to quickly, not do that. I'm going to move it over to our output file. And then I'm going to launch iTrace Toolkit. So Toolkit is the second half of this process where you take in the data you've gotten from your one or multiple studies. It can handle multiple at once, and you perform analysis on it. So to start, you need to create a database. So let me navigate to my desktop. And then, okay, so we go to the demo, output. I'm just gonna, output, and then I'll name it demo.db3. So this creates the blank demo for us. Next, what we need to do is we need to input the data. You can either input each XML individually by selecting this button, or you could import all XML files within the folder at the same time. And because all of our XMLs are within this output file, we can do that. So I'm going to tell it to do that. Let me navigate back over there. All right, so when you're in the folder you need, you just tell it to select folder, and it loads them both in. Now, I named them the exact same thing because I didn't go back and change, but hopefully when you guys do your sessions, you would change the name or the researcher who did the session, so you would have different stuff here. So if you want to perform analysis on only one or some of them, you can uncheck them, and any analysis will ignore unchecked things. For this, we're just going to do all of them, though. The first step is to come down here to analysis and map the tokens. This is where we will select that source ML file we generated at the beginning. So let me go and find that. So you'll select it right here. And if this is your first time doing this, you do not need to check this box. If you've done this already and need to overwrite everything, you can check this and it will do that. So I'll say identify tokens. This will take a long time if you looked at a lot of files or looked at a lot of files or looked at one file for a long time. And the larger the file it is, the longer it'll usually take. However, this is a very small example, so it'll breeze by quickly. So it's now mapped the data to the tokens. And what I'll do is I will open up the database here. And if I go to our IDE context, now it says right here exactly what source token the gaze was looking at. If you opened this up before I ran that, all of this data at the end would have been empty. But now, because we had the source ML file telling us exactly where every bit of text was, and our plugin data telling us exactly what file and what line and column our gaze was looking at, we can extrapolate what word they were looking at. Some of them are still going to be null because, you know, my mouse moved over empty white space or my mouse moved out of the file you were looking at, but it contains every single word or token I looked at. Additionally, I'm not too sure how familiar you guys are with XPath, but XPath is a way of getting information out of a XML file. This is the XPath that gives you exactly what the user looked at from the original file, along with the context of where it was. So like I mentioned earlier, if you wanted to look for if statements that were inside of functions, this is how you would do that. This tells you the exact context of what it was looking at. So it was looking at a name and a call and an expression and an expression statement, on and on. You guys get it. We're not done with Toolkit yet, though, so we'll come back. So the next step after mapping the tokens is to generate fixations. All we have right now is just individual raw gaze data of where our eye was looking at any given millisecond. However, eyes don't really work like that. Eyes will focus in on something and then dart over to the next thing to look at. So in order to calculate what our eyes were focusing on, we have 3 different algorithms to detect it: basic, IDT, and IVT. If you go to the wiki for Toolkit, and Dr. Sharif can link you guys to this, there are papers that go over each of the algorithms, what they do. It's not too important for this demo. I'm just going to be sticking with basic, but if you need to come and tweak any of the settings here for any of these algorithms, you can. So you set it to the one you want, close, and then click generate fixations. Now that's really fast, again, because the database is, the session was very small. But if I reopen, we can now go to our fixations tab, and we see exactly every single fixation that occurred during the 2 sessions. So right here, it's telling me that I stared at generate query data for 901 milliseconds, so 0.9 seconds. And I stared at load database file for 435 milliseconds. And this is going to be the bulk of the data you want, because you want to know exactly what the user was looking at. Real eye tracking data is going to be a little more sporadic because the mouse is very smooth for tracking. But for the eye, you know, the eye darts around all the time. But this will give you a very good idea of what token or what area of the code the user was looking at. Lastly, I'm going to go over querying. So at this point, you could take the data as it is and do whatever you want with it. But in order to help kind of speed up the process, we've added our own query fixation section. So you click this section and you're able to filter out any fixations that were generated based on whatever parameters you want to enter. So if you only want a list of file names, like if you only want file fixations that were on a certain file, you would type the file name here. If you only want fixations that looked at function names, you would type that here. If you only want fixations that lasted a certain amount of time, like between 500 to 1,500 milliseconds, you would enter that here. This is for a minimum and maximum file line, file column. You can set a minimum or maximum pupil diameter. If you want to filter between left and right separately, you just click this chain and then the slides move separately. And then you can choose what type to output it as. So very quickly, I'll filter this so that we ignore anything that is less than 500 milliseconds. And I will output this as a TSV. So if I click filter, at the moment, I have to go find this. At the moment, it actually puts the output inside the install directory for your toolkit. We're working on changing this, but just know that it will now be in wherever you install toolkit to. So if we look, there should be a TSV file in here. Yep, right here. So we open that up. We can look, it labels what every single column is, and then it labels the entire fixation data. I'll quickly do another one just to show you a different format. I'll do a DB3 filter. And now we have this database file, and it contains the fixations we wanted. So there's many different formats you can choose from if you're working with something. I know some languages support other formats better, so this is a great way to get the data. Additionally, you can come to the query, you can do the query fixations. You can export your current settings. This will generate a .sql file, I believe it is, that contains the exact settings that you want to run on. And then you can take that or write your own and click load SQL file and filter. And that will do the exact same process this does. Take your SQL command, filter out any fixations, and then output them in whatever format you desire. That was a lot. Are there any questions? I have one more thing to cover, but I kind of want to see if people have any questions for me.
He said that, or I think you mentioned there is something where you can use OBS and you can see real time where your gaze is.
Oh, Josh, he's asking about displaying the fixations on top of the replay. But you're working on that, correct?
Oh, yes. So yeah, so we're currently working on another tool, visualization, that will display them in a circle, like it'll print your gazes or your fixations on the video. But that's not done yet. That's very, very bare bones and not great looking. I can maybe hold on. Let me find.
Is that what you were asking? I think also if you want to see it live, Josh, correct me if I'm wrong. If you have an extended screen and they have OBS open on the one screen, the moderator can actually see the live screen,
yes.
right?
So it's kind of hard to show because it goes infinite. But if this was on your other monitor, kind of like this, you know, the person would be like a moderator would be able to see the OBS recording, or you would be able to have this streamed over to some kind of person watching over. And if you were asking about the like visualization part, this is an example of what we're working on here. So the red cursor, the red circle is the one that Core generates automatically, but the blue is the one that maps it itself. As you can see, it sticks to the mouse a lot better. We're still working on it, like I said, so we don't have a lot of examples to show, but we're working on this visualization tool. If it gets done or at least it's in a better state anytime soon, I will let Dr. Sharif know, and she can get you guys the early version of it to work around with. But that's where this is at the moment.
Yeah, we're literally currently working on it. We just collected data for it so Josh can test out,
Mhm.
his implementation. But other than that, just to, if you're worried about where the person is in time, you always have that iTracker manager open so you can see the person's distance. This is why it's crucial to have that open. Josh, I had a question. So let's say you have multiple, I know we named it the same here, but what if we had, one participant do, let's say the participant's name was P1, and P1 did 3 tasks, T1, T2, and T3. Okay, how would somebody go about, and let's say now we have 3 checkboxes here, correct? For all those. How would one go about seeing these? Would they need to go through the same process and then write their own query to see, for example, what did people, or wait, let me add to that scenario. So we have P1 doing task T1, T2, T3, and then we have P2 doing task T1, T2, T3. And now we load 6 files here, right? We generate fixations, we map tokens. How do we go about seeing everyone that just did T1?
Okay, so assuming that the name of the sessions are always T1, so if P1 and P2 both named it T1, you could go to, we don't have a way to automatically do this. This is the wrong one. You would go to your database file and you could go to session. And this contains everything. This contains just a list of the sessions. And what you would do is filter by task name T1. And then that would give you session IDs. And from there, the session ID will give you all the data. You might have to jump through some tables to get the data, but you'll be able to extrapolate every piece of data labeled T1. So if you wanted the fixations, you would go to fixation run, find the matching session ID, get the run ID, and then go to the fixations and find it. If you wanted all the gazes, you could just go to gazes. They have it directly mapped. The IDE context right here. Also, quick side note for you guys. This is a lot, this is a lot of data here. We have a database schema and an explanation of every table in the document, the instructions document I linked. So you can read through and figure out what everything is, because I know some of it's a lot, some of it might not be exactly intuitive at first glance. So there is that information available.
The reason I asked that is because you'll need to do that. You'll have to write your own query to make sure you get, let's say, just task 1 of all participants. So you can export those eventually. So I'm assuming everyone knows basic SQL, how to join. It's basically just to join between several tables.
Something else I would like to add, if you guys do any studies that look at different source code, it's recommended that you make different database files for those different source codes. You can bring them all in. So say I have someone looking at the source code of file A, and then someone else looks at the source code of file B. You could bring them both in here, but you would have to make sure you uncheck one of them when mapping tokens and then do the opposite when you map the other tokens. So it's generally easier just to have database A and database B for those. But you can be, however you want to do it. If you like them in all one big database, you can do that. Or if you want them split up, you can do that. Just be aware that if you try to map tokens for file B using the source ML from A, it's going to be we can't find anything. So just keep that in mind. And
we say this is because this has happened before.
Yeah, I think last semester, some of your students did that. Another important thing, when you run the source ML commands, make sure this position flag is set. Toolkit will take a source ML archive that doesn't have position set. But then when you get this data back, all of this will be empty because it didn't know where anything was.
Right.
So I have a question, Josh. For tasks that have multiple source code files that participant has looked at, how about those? Do I need to, if I want to map the tokens, do I need to just map the token of the entire folder? So is it going to work for a task or a file per se? That's my
So
question.
a task. So when I generated the SourceML archive,
It was on a folder, right?
it was on a folder, right? SourceML is very good with that. You can be very recursive with it. So in this example, these were all the files in the namespace. If
Okay.
I had looked at every single one of these, then the SourceML would have to contain it. The command I ran, if you do the -- archive, and then give it the folder to run on, it will go through that folder recursively and add every single file.
And can I ask, what is like, how many folders does it go like deep? Because some of my tasks have like several folders, like inside several folders.
It can handle the entirety of the Linux kernel. I know, I don't know exactly how deep it goes, but it can handle
so that's fine.
humongous projects. So yes, it should be fine.
That's fine. Thank you.
And I can show you quickly here if I open this up. The files are in these unit tags. So right here, this is controller CPP. If I minimize this, this is controller H.
I see.
And this is also the SourceML file is usually pretty big because it's multiple files and packed into one. But as long as you get all of them, you can, like, if you could theoretically do a SourceML of your entire computer, and then no matter what the user looked at during their session, it would handle it. But that would take a while. So it's better to try to find that happy medium between how many files do I stuff in this database versus splitting them up.
I see. So you would suggest, like, if there's, for example, like 11 tasks in a study, then you would have like 11 different databases for all of them.
Yeah, I mean, it depends on, it really depends on the source code. If the source code is wildly different and in very different spots, then yeah, you should probably have different databases.
Okay.
But if all of the tasks look at the same source code or the same, not even if they're not the same files, the same project, then yeah, you can use one big database for that.
Okay, perfect. Thank you.
No problem.
All right,
Any other questions?
Any questions? I'm recording this so that you can go back and revisit this again. I know it's early on, but it's nice to go and once you start collecting your pilot data, it's nice to go and look at this again because there is a lot, but it's a workflow, right? I just want to quickly go ahead, Josh. You had something?
I was going to say we also have the YouTube channel that has bite-sized tutorials on how to do every step. So you can go back and watch those at any time.
Right. Josh, could you share the screen with the iTrace demonstration, the Google Doc?
Oh, yes. Yes.
I just want to cover that. Yeah. So here, this is shared with you on Discord, right? Everyone has this link on there as a view. So those are the links to install. Okay, iTrace Core. Now in the lab, note that everything is installed on the machines there, but I highly recommend you doing this on your computer. Sorry, you need a Windows machine to do this. No Linux right now. No. Josh is working on it.
So Toolkit can work on Linux. Not Mac. I've been unable to get working on Mac, but Toolkit can work on Linux. Core cannot. Core is a Windows program. So your recording will have to be on Windows, but your data analysis can be in Linux. And I will try to get you guys a build of that soonish. So if you want to do your data analysis on Linux, you can.
You'll want that?
Core has to be on Windows. You have to do the recording on Windows.
Okay. The reason being is because, all the Windows APIs for the trackers are in Windows. So anyway, so these are the links. There's some detailed instructions how to set OBS up. Josh went through that. So read this over. Then you have the recording, right, where you launch Core. And then you have your screen recorder, right, where you record. Now, I just wanted to quickly go over the general workflow here. Yeah, no, that's important.
I just wanted to make that bold, yeah.
Let's make that in red or something so we know.
Red's a good idea, yeah. Let me do that. There we go. All right.
Yeah, so this is what I want to quickly go over. So with any study that you do using the iTrace infrastructure, this is basically the overall setup, right? Can you zoom that a little bit?
Yep.
Thank you. So the first thing you do is you decide what plugin you want to use. Atom, Visual Studio, Eclipse. I would stay away from Visual Studio. Eclipse and Atom are
Yeah.
much more
Yeah, this is depreciated.
stable.
So.
Just a very quick question.
Yeah.
Because I remember you said there's a plugin for Chrome.
And Chrome is also available.
What's interesting is that there's also an online version that you can access of VS Code. Do you know how that works or anything?
Right now, we don't support VS Code, but we're planning to add that in the future. Yeah.
Okay.
The reason is because VS Code blocks the line and column that we need to access. Without actually changing the source code, we can build a plugin for it at the current moment, at least. So anyway, you choose your plugin, and then let's say you choose Atom. You would set up Atom. You would open up the folder you need. This will all be done prior to your participant ever coming in, right? You want to make sure your environment is set up. So if you're using the lab computers, this is already installed with the latest version. But again, please install it on your local machine so you can learn how it works, right? Use the mouse as a proxy, as Josh showed us. Then you do the calibration twice. And we did this last week in the lab. Remember, we used iTracker browser where you saw the face that turned red and green. That should always be visible on the external monitor that the moderator sits on. Once that calibration is done and you have the correct distance where the participant sits, then you go and do the calibration in Core, connect the Core to the plugin. And then if you're doing screen recording at this time, you connect OBS to the Core, start tracking, then the participant, then you just sit and make sure your job as a moderator would be just to make sure they're not moving around too much, right? You want to get good data. Stop tracking before and after each task. So let's say you have four programs you want them to look at. Don't do the start and stop tracking, for all the 4 tasks. You want to have nice delimited chunks of gaze for each task. So start and stop for each task. Once you start and stop, you saw there are 2 files generated, one from the plugin, one from Core. For Chrome, I believe, Kangil, correct me if I'm wrong, for Chrome, the files are written on desktop, am I correct?
Yes.
Yeah, so
Or whatever the download folder is set by default.
I think
by
it's a
Chrome.
download folder because it just downloads.
so can you change that, please?
Yep.
Yeah, so whatever the download folder is. And then keep repeating steps 5 through 8 until all your tasks are done. And then you go and do the toolkit that Josh showed here. That's not the end though. All toolkit does is it maps tokens for source files and it generates fixations, right? Based on those 3 algorithms. We'll talk a little bit more about parameters and stuff. That's your first assignment that I'll introduce next week. But after that, you export the fixations and then you got to use your own stat package like R, Python, what have you, to actually look for statistical differences or any trends on the data. Okay. Toolkit, the job of Toolkit is to make your life easier so you don't have to deal with these large raw gazes. It generates these for you. Okay. Note again, Toolkit will not generate fixations on Chrome data because Chrome data is very ad hoc. Right? It doesn't know how to generate source ML from a random, first of all, it's not even source code. It's just probably a GitHub page, for example, right? So it's very different. The areas of interest are different. So we don't generate fixations from there. If you want to generate fixations from Chrome data, you have to write your own version of Toolkit for fixations. That's not hard either. We have done it. Kangil has done it before. So if you want to go that route and use Chrome, we can help you with that as well. And that's pretty much the workflow for the study. So there's a lot of stuff, but you just have to take it one by one and actually kind of get your hands dirty in the lab because there's no other way around it. You have to kind of go there and see what you're getting and do it at least a week or 2 ahead of time before the first participant actually comes in to do the real data collection. Any other questions? Josh, did you have anything else to add?
One more thing. I was told to save this for the end because it's a little bit different, but there is a feature in Core called Deja Vu. If you guys are running this on any kind of slower computers, that aren't able to keep up as much with what you're doing, you should use Deja Vu. So Deja Vu is this little toggle button here in the bottom of Core. So if I tell it to record with Deja Vu, what you need to do is make sure that your IDE is in a consistent spot. It's set up the exact same way every time. So you have one file open, all the way scrolled up to the top. Make sure this is still connected. Yep. All right. So what I'm going to do is I'm going to start tracking. It's going to look exactly the exact same for a while. I'm going to move my mouse around here. I'll highlight some stuff. I'll do a Control A. And then you go and you stop tracking. Now, in your output folder, there's this new file, out.csv. This contains all of the gaze data, mouse movement, and button information you just entered. And what you can do is go to this replay tab, click replay, but make sure that any other windows are minimized here. You just want the IDE and Core, and then you select this out.csv. And it will, and you have hands off the mouse, off the keyboard, replay everything you just did, but slower. This way, the plugin is able to keep up with the eye tracker and get more concise data. If you remember at the beginning, I said that there should be a one-to-one between the plugin file and the Core file, but there's always not, because sometimes the plugin file misses stuff. This is a way to get closer to that one-to-one. And you can make it even slower if you need, if you want like a whole, this would be ridiculous, but a whole 100 millisecond delay, you could do that. And this will take forever to do. Actually, I probably shouldn't have made it that long because now I'm going to be stuck here. But if any of your like own machines at home or stuff is a little slower, it can't keep up. I know you guys probably won't be using the eye trackers there, but this is useful because it gives slower playback, which gives you closer, better results.
Yeah, and I also want to add something that the reason we did this, and I mentioned this in class, remember we talked about how the function call cannot keep up with this is our solution for it. So we generally tend to have this issue with trackers that are more than 60 Hertz. So if you want to use the 300 Hertz tracker, now we just have to use Deja Vu. And it will play back everything slower. So then now it's actually collecting the data for the line column.
It's important to note that you will be using the exact same Core file. So if you do one study normal with the recording on, it will generate a plugin and a Core file. You need to make sure to move that plugin file out. And then when you run the Deja Vu replay, it will generate a exactly named replay file, but it will have the hopefully more accurate data. So I would recommend just renaming the first one like record and then rename the second one replay, but they will both use the exact same Core file because the Core data is going to be the same between them.
Right, that's an important point, Josh. Thanks for pointing that out. Does everyone get that part? So just make sure you rename it because it still generates that plugin file, right?
Mm-hmm. Yeah, it's going to generate the exact same because to Core, it's literally doing the exact same thing again. It's just this time, instead of you doing the eye and the mouse and the keyboard, Core is doing it. Otherwise, they're treating it like it's the exact same thing. So you have to make sure that it doesn't overwrite any previous data. Oh, all right, I'm free. That was perfect timing. Are there any final questions? If you guys have any questions later on, you can always ask Dr. Sharif and she can relay the question to me. Or she can give you my email. You guys can email me directly. But are there any questions right now I can answer?
Okay, awesome, Josh. I will definitely forward to you any questions that I'm sure there'll be questions in the coming weeks, but for now, it was a good summary of everything. Thank you.
All righty. All righty, I will head out then. You guys have a good day.
Thank you so much, Josh. Appreciate it. See you later for the meeting.
Yep.
Bye.
Bye.
Bye, Kong Il.